once again. So now today we will be discussing probability distribution. We have discussed probability, what is probability theory. We have in probability theory we have seen different types of events, then we have seen conditional probability, total probability and Bayes theorem, and now going a bit further to it, now we will be seeing what is probability distributions. So, in this probability distribution, first I will be explaining what is a random variable, then I will go on to explain what is a probability distribution. We will discuss discrete probability distribution, what is a continuous probability distribution, what is a discrete probability distribution. We will also see what is the we have seen what is the mean and variance given a set of numbers. Now we will see mean and variance with respect to a random variable, mean and variance of a probability distribution essentially. Then we will discuss what is the Chebyshev theorem. With that we will end this class. Now first is what is a random variable. So random variable, if we see the definition, random variable is a function that associates a real number with each element in the sample space. Okay, suppose suppose I have tossed two coins. I have tossed two coins, and when I toss two coins, what do I get? Let me take the pen. Okay, when I toss two coins, what is my sample space? My sample space will be say, my sample space will be say head, 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 tail, then again tail, head, tail, tail. This is my sample space. Okay, so what happens? If I am interested in finding out number of heads when I toss two coins, so what the number of heads I get? This is number of heads is 2, number of head is 1, here number of head is 1, here number of head is 0. So this is the random variable essentially. So it's a function that associates a real number with each element. It associates a real number with each element in the sample space. A random variable is a variable whose possible values are outcomes of a random phenomenon. That's also we can define a random variable. So random variable, now this random variable may be discrete, may be continuous. Okay. So now with the knowledge of random variable, now we can define what is a probability distribution. When we do an experiment, any random experiment, we will be getting different sort of outcomes. What are these outcomes? These outcomes are the values of the random variable, right? Now this random variable, these values, they have a certain probability of occurrence, like in the like if we toss a coin, what is the two outcomes, head and tail? We have a probability of occurrence of head and tail. If I let me take it in this way, what is the probability of getting head? So probability of getting either we will get one head or we will get 0 head. Means if it is a tail, it is a 0 head. And what is the probability of getting one head is 0.5 and probability of getting 0 head is 0.5. So that means the values of the random variable when we do an experiment, the values that we get of the random variable and the probability of occurring of those values, these two things put together is probability distribution. Okay. So what is probability distribution? Again I am repeating, probability distribution is nothing but the values of the random variable as well as the probabilities of occurrence of these random values, all the random variables in an experiment. So how we define it? The probability distribution of the random variable x provides the possible values of the random variable, all possible values of the random variable along with their corresponding probabilities. That is the probability distribution. So we will be having, since random variable may be discrete, random variable may be continuous. Discrete means it will take some finite values, 1, 2, 3, 4, some finite values, may not be 1, 2 as well, but it will take some finite values. And what it is continuous? Continuous means it can take any value within an interval. So if the random variable is discrete, then we call it discrete probability distribution. If the random variable is continuous, we call it a continuous probability distribution. Fine. So now a probability distribution, we can describe a probability distribution in the form of a table, in the form of a graph, or in the form of a mathematical formula. We will see. Now first we will define we will see the condition of a probability distribution function. So what is a probability distribution? First, when I tell that random, suppose my random variable is x, then what is the probability of x? That I will define it as an fx. What is the probability that x takes? That I can, let me define it as fx, or you can tell px, any x. It's just a function of x. Basically the probability of x, fx is nothing but the probability of x. So the set of ordered pairs, x f x, this set of ordered pair f x f x is a probability function, or we can call it a probability mass function or probability distribution. We can call it a probability distribution function or probability mass function of the discrete random variable x. Now here one thing please note it, see I have mentioned here of the random variable x, and here I have capital X and here I have used small x. This is a general convention. When we talk of the random variable, we always use capital letters, and when we talk the value that the random variable takes, we usually denote it by small letters. Now this x is the value that this capital X takes. My random variable is capital X and x is the value that the random variable takes. Now when I am tossing a coin, tossing two coins, I was getting 2 head, 1 head, 0 head. So this value is 2, 1, 0. That I will denote it with a small letter, but the random variable I will denote it with a capital letter. It is a general convention followed in all the books. So if for each possible outcome x, so for a discrete x f x to when we can say there is a probability mass function or a probability distribution function if it satisfies this following conditions. What is this? First of all, f of x should be greater or equal to 0. Okay. What is f of x? F of x is nothing but f of x is the probability of x. So it should be greater or equal to 0. In fact, it should be less or equal to 1 as well. And what is summation of fx x f x? Sorry, summation of f x x summation of f x for all values of x will be always 1. Probabilities will be always 1, isn't it? So the probability of getting 2 head, probability of getting 1 head, probability of getting 0 head, all probability put together, summation should be always 1. And probability of at x is equal to x is nothing but we designate it by fx. So fx we can tell it's a probability density function, probability distribution function when it satisfies these two conditions basically. Fx should be greater or equal to 0 and fx summation of fx should be 1. So here is an example. So a coin, I have tossed a coin twice. The example what I have just now what I have given. So possible, these are the possible outcomes. So h is ht, tt, th and tt. So what if my event if I am considering is that getting heads. Okay. So what is my getting getting tail. So getting 0 tail is when I get h's, that means I got 0 tail, both I got head. Then getting 1 tail is either ht or th, getting 2 is tt. Okay. Now what is the probability of this? Say how do I find the probability? So sample space size is 4. So I got 0 head, how much I got? What is the just only how much is favorable to this event of getting 0 head? That is 1. So what will be my probability? 1 by 4. So probability for this will be my 1 by 4. Okay. Now what is for 1 getting 1 head? My favorable outcomes are 2, ht and th. So what will be my probability? I am writing here probability will be 2 by 4. And getting 2 head, getting 2 tail is just 1. Again it is 1 by 4, right? So this if I can in the last slide I told this probability distribution I can define it in the forms of a table, in the form of a graph, okay, in the form of a function. So this is if I express this maybe in the form of a function, this is what it is shown here, and it is this one, this maybe it is in the form of a function, this is in the form of a graph. Say and y-axis I have given the probability, x-axis is the different values that the random variable take. Random variable may take the 0 value. Random variable is with respect to an event always. Okay. So that what is my event? Getting a tail. So the random variable may be 0, 1 and 2, and this side it is the y-axis is the probability, and this is if I explain it with the help of a graph. Fine, a small example now to understand this concept. What it is given? First go to the question. A shipment of 20 similar laptop computers to a retail outlet. A shipment of 20 similar laptop computers to a retail outlet contains 3 that are defective. Out of 20, 3 are defective. If a school makes a random purchase of 2 of these computers, find a probability distribution for the number of defectives. See, here it is asked that we have to find the probability distribution for the number of defectives. If the school has purchased 2 computers, what may be the number of defectives in this case? It has purchased 2 computers, right? So, what may be the number of defectives? Number of defectives may be, there may be 0 defective, there may be 1 defective, there may be 2 defective, at most 2 defective. So, number of defective will be 0, 1, 2. That means the random variable will take the value 0, 1 and 2. Now, we have to find out what is the probability of 0, what is the probability of 1, what is the probability of 2. This is the probability distribution, isn't it? So, that is what probability distribution is, the value of the random variable, all the possible values of the random variable along with this probability of occurrence. So, how do we find out what is the probability that 0 defective? So, what is the total sample space? Total sample space is the total 20 computers. Out of 20, I am picking 2. So, it will be 20C2. Since we have seen, remember what is where we will use permutation, where we will use combination. Now, here these are indistinguishable, isn't it? So, it will be 20C2. The whole sample space is 20C2. So, and how much, what we want to see? 0 defective. That means in 20 there are 3 defectives. How many non-defectives are there? Non-defectives are 17, and we want to find out what is the probability of picking 0 defective. That means the 2 computers that we have purchased, that means we got it from the good ones, good 17. 17s are the good ones. So 3C0 into 17C2. Say this one. Okay. Similarly, for 1, same, denominator is 20C2, and that means we have 1 defective, means from that 3 defective we got 1, and 2 another one we got it from the 17. Similarly, 2, from 3 we got 2, and from the 17 we got 0. Okay. So, if we write in tabular form, this is the tabular form. In the tabular form, the probability distribution of x. So, we have seen how we write in a tabular form, we have seen how we write it in expression form, how we write it in a figure graph. So, now what is cumulative distribution function? What we have seen here, probability of getting 0 defective, 1 defective, 2 defective, we are concerned of a particular number. Okay. Now, if I am asking this the question of head and tail only, question of getting, when I am tossing 2 coins, what is the probability of getting either 0 tail, 1 tail or 2 tail, maximum 2 tail I can get, right. So, I cannot obviously get 3 tails. Now, if my question is what is the probability of getting at most 1 tail? So, what is the probability of getting at most 1 tail? That means at most 1 tail means there may be 0 tail as well, 0 and 1. So, I have to find the probability of occurrence from 0, probability of occurrence of 0 and probability of occurrence of 1. So, probability of occurrence of 0 plus probability of occurrence of 1, that will give me at most 1. So, what is that? That is the cumulative distribution function. We have seen cumulative frequency distribution, remember? So, that is the same question, same concept. So, cumulative distribution function is f of x is probability that x, that is the random variable, is less than or equals to x, is this summation of f t, where t is range less than or equals to x. So, here at most 1 means f of 0 plus f of 1, okay, that is cumulative. Now, continuous probability distribution. Continuous probability distribution, when the random variable is continuous and the random variable contains any value in a range, then the distribution that we get is a continuous probability distribution, that will not be a discrete probability distribution. Now, taking any value in the range, and when we tell that, so it can be any infinite value, any value within the range, it can be. So, now like suppose if I ask the height of a person, you can tell this, okay, height of a person is say 5.8, okay, but will it be exactly equal to 5.8, or it is equals to 5.8000001 or 5.8123455, something like that. It is very difficult to tell exact value. It is almost the probability of getting an exact value is almost equal to 0. You cannot, such minute scale measurement is not there to measure. So, that is why what we, in case of continuous probability distribution, what we tell is that a continuous random variable has a probability of 0 of assume exactly any of its value. and when we talk of continuous probability distribution, we have a probability of 0 assuming exactly of any of its value. Like in the discrete, we have given what is the probability of 0, 0 head, 1 head, 2 head, exactly a value. But when you are talking of continuous probability distribution, probability of taking exactly a particular value we cannot define. So, that is basically 0, and since that is the situation, so we cannot write a probability distribution table, we cannot represent it in the form of a tabular form. In tabular form we have to give specific value, right. So, in continuous probability distribution we can only represent it either using a function or using a graph. So, this example, whatever example I told you just now. Okay. So, now like probability distribution function what we have seen, or probability mass function for discrete random variable. Similarly, for continuous random variable we call it a probability density function. So, for probability density function the condition it has to satisfy same like that, that is probability f of x is greater or equal to 0 for x belongs to any real number, and integration of fx dx is 1. Here it is integration. Now, here one thing which is very important to remember, to note rather, and when I am talking of discrete probability distribution, then value of fx cannot be greater than 1, because in case of discrete probability distribution, what is fx? Fx is the probability of the occurrence of x. Fx is nothing but fx is the probability of x. So, probability of x cannot be greater than 1, right? Any probability means that it has to be within 0 and 1. So, in case of discrete, fx is the probability of x, but in case of continuous probability distribution, fx is not the probability of x, it is the probability density function. Its value can be very well, greater than 1 as well. So, it is a density function. It's just in a curve, when we draw the curve, it shows how much probability is concentrated at that near that point, basically. How much probability is concentrated near that point. Fx basically will give us the shape of the curve, and when we have to find out the area of a particular interval, it will always be the area within a particular interval. So, we will have to find the area. Okay. So, that is why it is integration. So, remember, for discrete density probability density function, my fx can be greater than 1. So, do not get confused, why is this is probability, then why it is greater than 1. It is not probability, it is the probability density, how much it is concentrated at that point, how much probabilities are concentrated at that point. Okay. So, now there is a small example. Suppose that error in the reaction temperature is degree centigrade for a controlled laboratory experiment is a continuous random variable x having the following probability density function. A probability density function is given. So, it is given fx is equals to x square by 3 for a particular range. What is the range? X varies from -1 to 2, and in other places it is 0. Okay. So, we have to verify that fx is a density function. Okay. See here, when x takes a value very near to 2, then we will get fx greater than 1, you see. That is what I have told in the last slide. Okay, that is we have already discussed. Now, we have to verify that fx is a density function. How will you verify that fx is a density function? To verify that fx is a density function, it has to satisfy those two conditions what we have seen. What are the two conditions? First is fx should be greater or equal to 0, right? And integration of fx, what the range, should be equals to 1. So, greater than, from the expression what is given, it is obvious that it is greater or equal to 0. From -1 to 2, it is x square by 3. Definitely, it is not less than 0. It cannot be less than 0, and elsewhere it is 0. So, it is greater or equal to 0. First condition is already satisfied. Second condition, from infinity to -infinity to infinity, it should be 1. That is the second condition. And if we just do the integration, then we will just see the integration. It is given here. Then we will get 1. So, it satisfies both the condition, then we can say fx is a density function. Next question, we have to find out the probability between x of 0 to 1. Nothing, it is just fx integration from 0 to 1. See, what is fx? Fx is x square by 3. We have to just do the integration from 0 to 1. Okay. So, gradually we will be getting many such problems where your knowledge on integration and differentiation will be necessary. So, please, you have already learned it in your school level, and higher secondary level, may not be in school level, of course, and higher secondary level definitely. please brush up your knowledge on differentiation and integration. For many problems like here we have done, this is a simple integration, of course all of you will remember that, but if any of you have forgotten, please brush up that, so else it will be difficult for you to understand few of the problems. Okay. And as I have promised in my first introductory lecture that I will be taking lots of examples. See, for each concept I will explain, and accordingly I will give one example. Now, what we have discussed for cumulative distribution function for discrete case, same is the case cumulative distribution function for continuous case. Cumulative means from till x, whatever x we specify, from minus infinity to till x, that is the cumulative distribution function. Same the concept of discrete. Okay. Now, how do we find the mean of a random variable? We have seen how to find out the mean of a set of numbers. Okay. Now, instead of taking, let me give you another example. Suppose I have two coins, and suppose I have tossed the, let me take the graph paper. Okay, I have tossed two coins. Suppose I have tossed two coins, say 16 times. Okay, I have tossed two coins 16 times, and 4 times, when they say 4 times, I got no head. 4 times I got no head, only tail like that. Okay, and suppose 7 times I got one head. Okay, and suppose 16, so it will be 5, right? 5 times I got 2 head. Okay, so now what is the average number of head per toss? Mean is what? Mean is average, isn't it? So what is the average number of head per toss? I am tossing 2 coins, right? So what is the average number of head per toss? Average number of head, how will you find out per toss is? So 4, isn't it? So what is 4? I got 0 head. 0 into 4 plus 1 into 7 plus 2 into 5 divided by how many? 16. Okay, this, first let me rub it. This thing I am writing in top, this can I not write it 0 into 4 by 16 plus 1 into 7 by 16 plus 2 into 5 by 16. Hence out of 16 I got 4 times 0, out of 16 I got 7 times 0, 5 times 1 head, out of 16 I got 5 times 2 head. What is this? This is relative frequency distribution. Relative frequency distribution is nothing but probability. We have discussed it, remember, in our second lecture. So this same expression I can write it this way, right? So what if I calculate it, I will be getting something, whatever you calculate it and find it out. So this is the average of that. So that's how we find a mean, right? Similarly, so how we found out the mean? That means what are the different values that a random variable takes, as well as the probability of that value. 0 into what was that? 0 into 4 by 16, right? 4 times we got 0 head. So 0 into 4 by 16. 0 is the value of the random variable, and 4 by 16 is the probability. That is the relative frequency that I got 0 head. So what is 4 by 16? Is nothing but the probability. So similarly, so when I am interested in the mean of a mean is also called the expected value. It is also termed as E. Mean of a random variable. It is designated as described as mu. Sometimes we call it as expected value. It is written as mu. It is also written as E. So what is mu or E of x? It is nothing but x summation of x fx. What we have just now we have seen. What now we have seen? Remember this one. This is 0, 1, 2. This is what x, and what is this? This is fx. Summation of x fx. Okay, this is if x is discrete, then summation of x fx. If x is continuous, then just integration of x fx. It's the same thing. So that's how we find a mean of an expected value. So it's a simple example is there. A lot containing 7 components is sampled by a quality inspector. The lot contains 4 good components and 3 defective components. Okay, there are total 7 components, out of them 4 is good and 3 is defective. A sample of 3 is taken by the inspector. Find the expected value of the number of good component in the sample. Okay. See, X represents the number of good component in the sample, so we'll have to find out the probability distribution of X. How many good components, what value that a random variable X can take? Random variable error, we are interested in number of good components. So how many good components are there? There are 4 good components, but we have taken 3. So the random variable can take either there are 0 good component, 0, 1, 2, 3, isn't it? So basically X can take the value 0, 1, 2, 3. See here, X can take. So what is f of X? F of X, the 7 is this one. 7C3 is the total sample space. And out of 7, how many good components? Good component is 4. We are interested in finding the good component. So we are taking all the X components from 4, and remaining how many are remaining? 7 minus 4 is 3. And from this 3, how many we are picking? Total we are taking 3 components. Out of 3, this X is the number of good components, and from this 3 we are picking the other component, that is 3 minus X. So this is the function, probability distribution function. So we can calculate this. So we found out for F0, F1, F2, F3, we can calculate it. Okay. So now we need to find out the expected value. Expected value is summation of X Fx. So this the X is 0 into 1 by 35, 1 into 12 by 35, 2 into 18 by 35, 3 into 4 by 35. Just put it in the expression and you get the value, right? Okay. You can check it again. So on an average it will contain 1.7 good components. Now mean or expected value of Gx. If we are interested in finding the expected value of a function of X, we have seen how to find out where X is a random variable. We have seen how to find out the expected value of X. Expected value of X is nothing but summation of X Fx if it is discrete. Now we are interested in finding out the expected value of a function of X. Say X may be 3x, X may be x square, x cube, or 3x plus 2, anything. So if you are interested in finding out the expected value of function of X, so a function of X I am terming it as a Gx here. So it is same as this, just summation of Gx Fx. Instead of X I am writing Gx, that's all, that's the difference. Okay. So using this, this one simple example is there. It is very simple, you will be able to do it yourself only. Just quickly I will go through it. Suppose that a number of cars that pass through a car between 4 p.m. and 5 p.m. on a sunny Friday has the following probability distribution. The value that the random variable can take is 4, 5, 6, 7, 8, 9, and this is in the second row is the probability of this particular thing. So now we have to find out the find the attendance expected earning. Gx is equal to twice x minus 1 represent the amount of money in dollars paid to the attendant by the manager. So this represents the amount of money in dollars paid to the attendant by the manager. So we have to find out the attendance expected earning. So that means the average earning. Average earning, how will I find? So it will be Gx Fx. So Gx 2x minus 1 is Gx. So x will take what value? X will take 4 first, x will take 5, x will take 6, 7, 8 and 9, and this into Fx. Whenever x is taking value 4, we will multiply it by 1 by 12, and by x is taking value 5, we will multiply it by 1 by 12, x is taking 6, we will multiply by 1 by 4, likewise. See here. Okay. Just we have substitute different values for x, and accordingly whichever values we have taken for x, that probability we will be considering. That's all. Now there are simple laws of expectation. Some basic laws we have. So what is the expected value of a plus bx? Always remember, expected value of a constant is the value itself, the constant itself. So here expected value of a plus bx, expected value of a is a itself. Expected value of 2 is 2, expected value of 10 is 10. So there is no, we cannot find an average expected value that is the average value of a constant number. So here it is E of a plus bx, so obviously it will be a plus b into E of x. Okay. Similarly, expected value of x plus y, if we have two random variable x plus y, what is the if we are interested in finding out the expected value, so it will be expected value of x plus expected value of y. Expected value of E of xy is equals to E of x into E of y. However, this is applicable when x and y are independent random variable. So now I think I'll stop this lecture here, and though initially I told that I'll be covering variance also and Chebyshev theorem also in this lecture, but time may not permit, so I'm stopping this lecture here. In the next lecture again I'll start from the variance of a random variable. Okay, thank you.